Do you want to do a sine or a cosine graph?
Sine.
Let's do a sine. Let's do a sine graph of -3 sine of, I don't know, 0.5 theta. Now what I've done to this particular graph, and this might show up as a 1/2, it doesn't really matter, which is worth stating. Same graph, you don't need to erase anything. That could show up as a theta over 2. Does everybody see how that's the same graph? 0.5 means times 1/2 or divided by 2, they're all the same thing. All right, so this graph actually has some order of operations calculations to it, and this is what you're going to be doing for homework. When I have a graph that looks like this, there's a coefficient in front of the trig, there's something with the theta, it means it's not a 2-column graph. It's far more columns than that, and that number may go as high as 5. And the order of operations for trig goes something like this. Your first column in your table, I should put column 1 in there, is always going to be theta, the number of radians that you were asked to graph. That's never going to change. Theta is always where I want to start. So column 1 is always going to be theta. Column 2 is going to be, what is it you want to do to theta? So if there's any math to be done on theta, if you have to multiply theta by 3, if you have to divide theta by 2, if you have to add 6 to theta, if theta is not alone, that'll be your column 2. So math that needs to be done on theta. That value goes in column 2. Your third column is going to be the trig. Any trig that you need to do is going to happen in the third column unless there was nothing to do to theta, and then it'll be the second column. Now I'm going to write in there the particulars for this one. I'm supposed to be taking the sine of theta over 2. So what I'll be writing in column 3 is the sine of the angle I found in column 2. Does that make sense? So in column 2, I figured out what theta divided by 2 actually was. In column 3, I'm going to take the sine of it. If I have a fourth column, it'll be a coefficient. So if the sine, the cosine, the tangent, the secant, the cosecant, or the cotangent has a coefficient, that will happen in column 4. So in this particular question, I'll be doing 3 times what I just found in column 3. The sine of theta over 2 is the answer that's sitting in column 3. Does that make sense? I'll multiply it by 3. I think it's 3, right? Did I write 3? -3. Thank you. And then last but not least, if there was any addition or subtraction in the question, and I didn't do that to you just yet, that would happen last. If there's any adding or subtracting to the entire trig function, like if I were to have put a +2 on there, that would be the last thing that you calculated. I'm not going to do that to you just yet. We're going to start pretty simple, not excruciatingly simple, but pretty simple. So I'm doing 2 things differently in this graph. I'm changing the domain, which means the graph paper I choose has to accordingly match. But I'm also adding some order of operations stuff here. How many columns do I need to get this graph down on paper?
4.
I need 4. 1 for theta, 1 to divide it by 2, 1 to take the sine of that answer, and 1 to multiply by -3. You follow that? Okay, so let's add in some columns here. I'm not going to go all the way out to -2 pi, so it's okay that I kind of went into my graph paper there. I'm now going to put the titles into those headings. If this is theta, this column is going to be theta over 2. What's column 3 going to say? Sine of, and I always have to write what was there before. So that's the sine of theta over 2, meaning it's the sine of what was in the column just before it. And what will be in this column right here? That'll be -3 times the sine of theta over 2. And the stuff that I've drawn in green is what I already had, and the stuff that I've drawn in red is what I'm adding on. Does everybody see where I got that from? Now again, you can do this with your calculator as long as you know how to. So we've already put these into our calculators list 2, correct? Okay, so what am I going to do in list 3 of my calculator? List 2 divided by 2. Does everybody know where Dan Paulhemus is getting that from? And now I'm going to take a moment and I'm going to take all those numbers and round them to the nearest tenth place and write them on my table. This is where the work that you're going to be showing on tonight's homework is going to land. Does everybody understand this? Okay. So I am going to write, oh gosh, I need a calculator. Or I can shrink now. Maybe. Let's try doing it this way. Coming over here. I should know this. It's just going to go backwards. That was kind of stupid. Okay. Just do it this one. I think I wrote 7 up there, even though now it looks like 8. Oh, sorry, these are positive. 1.3 and 1.6. I'm less concerned, far less concerned, at the accuracy of your rounding in these middle columns, because the calculator is where I'm actually working. I'm not doing any math on these. I'm just showing you that I did indeed find the values. When I finish this table, what are the only 2 numbers in this first table of values piece of data that I'm really going to care about? The original input and the very last output. That's going to be my coordinate point. So the numbers in the middle, if I round them wrong, it's no great shakes, as long as you're close. It's the number at the beginning that's really important, and the number at the end. Okay, let's go ahead and try the next column. What am I going to put into column 4 of my calculator, but column 3 on my paper? Sine of the list right before it, which for you guys would be list 3. So now I'm going to go to my calculator. I'm going to right arrow over to list 4. And in the heading, I'm going to type sine list 3, the one just to the left. And there's those answers. Put them into your graph table. Everybody okay with where I'm getting these from? So now I need, okay, so in the last column we put in -3 times what was in our calculator as list 4, and now I'm just going to plot points. So I'm going to go left 6, up 3, and I'm going to put a dot there. Left 6, up 3. I'm going to change these scales. That'll be 3, that'll be 2, that'll be 1. Is everybody okay with that? Just so it fits. I'm going to go left 5, up 2.9. Left 4, up 2.6. Left 3, up 2.1. And keep going. This graph, when it's done, ends up looking something like this. And that is -3 times the cosine, no sine, of theta over 2. Okay, we're going to do the tangent graph next. And what's different about a tangent graph, you'll notice if you go all the way across the columns for sine and cosine, they have values everywhere. Every other graph has this one little thing show up somewhere that's going to create some grief for you. And that little thing is right here. And that's the fact that this thing is undefined. So when I go to graph the tangent graph on my calculator, I'm going to be graphing this particular graph from 0 to 2 pi. So we can start by filling in our pi values. But when I go to do that on my calculator, let's take a moment and clear out all the lists that we've already filled in. And again, you can do that real quickly by just going up, hit clear, back down, go left. Up, hit clear, back down, go left. And I want to clear out everything except list 1. So that list 1 has in it my radian values. And in the heading for list 2, I'm going to try real hard to type tan of list 1. Why would it be giving me that error message? And specifically, those undefined values, if you'll recall, are coming from division by 0. Remember, a tangent is a sine over a cosine, so that's a domain issue. They're saying, meh, can't do it. Now your options are as follows. You can take out those particular radian measures that will be undefined and just write them on your table as undefined. The calculator will do the rest of them for you. Or, and this is the one I'm going to choose, we can calculate these by hand, knowing full well that I've noticed that a lot of these have patterns. And so I'll just look for some patterns. And specifically, what I'm going to have you do is just write in the exact values for starters. We're going to count in our heads by 30s while we're counting in our first column by pi over 6s. And I'm going to fill in the exact values. The exact values for tangent go something like this. The tan of 0 is 0. The tan of 30 is rad 3 over 3. The tan of 60 is plain rad 3. The tan of 90 is where I was undefined. So far, so good? Okay, now I just have to take just a minute to figure out the next two, and then I think I might be on to something. 4 pi over 6 is the equivalent of 120. It's 4 30s. And that has a reference of 60. That means the tangent of 60 in this quadrant is going to be the same as it was in that quadrant, except negative. Now, noticing that in that first set of 3, there were really only 3 answers there. If I'm starting with the biggest one, where do you think I'm going? I'm going to go smaller. So the next one would be negative rad 3 over 3. And the next one would be 0. Now, from 0, if you had to guess, where am I going to go? Same place I went before. When I had a 0, the next number was rad 3 over 3. The beautiful thing about trig functions is their patterns. And 9 pi over 6, right after the rad 3, happens to coincidentally be the other place I was undefined, just like it was when I saw it up here. And I bet you could finish this chart. Now, the reason this one's so much easier to do by hand is actually because there were only really 2 values in there that I don't have a number reference for. Some of them were positive, some of them were negative, but they're all rad 3s or rad 3s divided by 3. So if I just figure out what a rad 3 is, I've just gotten about 8 points. And if I then divide it by 3, I've gotten the other 8 points. All right, I'm exaggerating, but you get the idea. So tell me what a rad 3 is to the nearest 10th. It's a 1.7, so I'm going to make every place there was a rad 3 be a 1.7. If it was negative, I'll make it negative. And every place there was a rad 3 over 3, go with 0.6. Is it really closer to 0.6?
Yeah.
Okay. I'll make it a 0.6.